Hi guys, this is Miss Eisencraft and I'm here today to talk about or to do notes with you on how to write quadratics in vertex form when you are given a graph. The last couple weeks we have been graphing given the equation in vertex form and we're going to go backwards. So much fun. Okay, so this is the form for an equation, a quadratic equation written in vertex form. Y equals plus or minus a, x minus h squared plus k. So if you remember, the a value tells us if it's opening up or down, right? And also, if a is 1, like what is the pattern? How narrow or wide is it? And so this it also tells you something about the narrow or wide or kind of normal, right? And we'll talk about that. It's a multiplier. You can multiply the pattern by whatever a is from the typical width of a parabola. Now, h and k are the vertex, and it tells you how much it shifted right, left is h, and up, down is k. What can be a little confusing is this minus in the equation. So the vertex is just hk. But remember, when it says minus for h, it moves to the right. When it says plus, it moves to the left. Plus for k means up, down for k, sorry, minus for k means down. Okay, so let's just get going and talk about how we could go backwards. We want to always remember the parent function over here. The parent function is just y equals x squared. So really like the a value is 1, h and k are 0, 0. So really the parent function of a quadratic is centered at the origin, or 0, 0. And then the pattern is, if you look, out 1, up 1, out 2, up 4, and you can't see the other one. Out 1, up 1, out, up. So if we see this pattern, at least here, we will know the a value is 1, okay? And if it is different at all from that pattern, we will then be able to determine what the a value is for that equation. Ignore background noise. Okay, so this first one, I think it's easiest to first identify the vertex. So if we look here, let's just say the vertex is 3, negative 4. Okay, so the vertex is going to be important for sure. And then you can also say, okay, it shifted 3 to the right from the parent function and 4 down. And we know that that is movement with the h and the k. So we know the 3, 4, it has to do with h and k. We also can describe it as a transformation, and specifically a translation, 3 to the right, 4 down. The a value, what we're going to do is from the vertex, we're going to see how was this u shape created. And first look at your scale. This is good. It's going by ones. So this parabola was built by going out 1, up 1. Okay? Out 2, 1, 2, 3, up 4. So that's what I like to call normal width of a parabola, or a value of being 1. You can also just say, look down here, if you go out 1 from the vertex, how much do you have to go up to hit the graph? 1. That number right there in quadratics is your a value. Okay? We also know out 2, up 4. So the a value is 1. And it's positive 1 because it's opening up. So right now we have enough information to write our graph, or to write our equation. Y equals, we'll put 1 here, but remember it's like you don't really need it. Okay, x. Now it moved the 3 to the right, so we write minus 3. Don't forget the squared guy there. And then it moved 4 down, minus 4. And remember the vertex is opposite, comma, this number. It looks good. You also could go to Desmos and type it in and make sure that it makes this exact graph as a way to check. And again, the 1 is not necessary because if you multiply by 1, it doesn't change. Okay, let's do another one. Okay, this guy, first thing I'm going to do is identify the vertex. Make sure you do x first. Negative 2, negative 4. Negative 2, negative 4. Now for the pattern, when we go look at the scale, it's counting by ones. Oh, good. When I go out 1, it looks like I have to go up 1, 2, 3 whole units to get to the parabola. Okay, when I go out 1, I have to go up 3. I can't really see the next one, but that is enough. There is your A value right there. When you go out 1, how far do you have to go up? Because that would tell us that this got multiplied by 3. Okay, we have enough information to make our equation. Y equals 3. Now, it moved 2 to the left. So you could write minus -2, but we know subtracting -2 is the same as adding. Another way to really think about it is just take the opposite of this sign in the equation and then take this sign. Really easy to get these signs mixed up. Okay. And again, you can check Desmos just to see if you're doing it right. Okay, third one. Here we go. The vertex is -2, 1, +1. And this is weird. Okay, no, I shouldn't say weird. So when you go out 1, it appears that it's like it's not going up a full unit, maybe only a half. We can't be sure. So let's go out 2, and it looks like when you go out 2, you're going up 2. Okay, so we know this is our A value. And sometimes when it's not exactly on a line, you can't really tell. But if we remember the typical width of a parabola, right, does this. And it looks like, okay, the A value, whatever the A value is, let's say, we're not sure. Well, this looks like it shrunk. We're not exactly sure. But the 4, instead of going out 2, up 4, it looks like you went out 2, up 2. So what do you do to 4? What can you multiply 4 by to make it 2? It looks like it got cut in half. And so this would be 1/2. So we could see this one, so that would tell us, yes, this is a half. Okay, so the A value is a half. So we would have Y equals, you could do 1/2 or 0.5, X, 2 to the left is plus 2 squared, 1 up is plus 1. And the only reason I say it is sometimes students, whenever it doesn't go up all the way, they automatically think it's, oh gosh, I'm so sorry. Can't see. You can't, sometimes they'll think, oh, it's always a half, and sometimes it's actually a third. So sometimes you have to keep looking at beyond the out 1, up 1, you need to look out 2. We could see that it landed exactly 2 up, so that we could see the multiplier was 1/2. If there was room, if we went out out 3, it would be up 4.5 or 4.5. I'm sorry you couldn't see me writing that one. Okay, last one is an upside downer. What? Okay, let's find the vertex. 3, 1. Okay, so the next thing we need to know is the A value. All right, it looks like when you go out 1, you go look at the scale, make sure it's counting by ones. It is. You're going down 1 and you're right on the graph. So really the A value is -1. So, and then when you go out 2, down 1, 2, 3, you can't see it, but this is enough information to tell us our A value. Okay, so now we have Y equals negative, and you can put a 1 or just a negative. It shifted 3 to the right, X minus 3 squared and 1 up. Boom. Right, so the main idea here is get the vertex, get the A value. When the A value is a fraction, it can be a little bit, or when it's a compression, a little bit wider, you might have to look at the pattern a little bit further to make sure you can determine exactly what this is. Okay. All right, good luck. Lots of fun practice this week with writing equations when given graphs. All right, see you later.